What I'm going to talk about today is essentially a summary of a book manuscript that I just delivered to Princeton University Press for their review. And it contains some shocking claims about the history of England and, in fact, about Western society in general. And the key question of the book is, to what extent are social outcomes socially versus genetically determined? And, you know, it could be the case that social outcomes are genetically determined, but they're also perfectly modifiable. And so a second question is, to what degree can life outcomes be changed by social interventions? And so we'll see that there's going to be these two questions. What's the actual transmission mechanism? And to what extent can social interventions change that transmission? Okay? And the answer is going to be that for England from 1600 to 2025, the evidence is largely that about 60% of life outcomes are determined by people's genetic inheritance. About 40% is just random chance, and roughly 0% comes from social causation. And so I'm afraid, in some sense, this is a finger in the eye of the history department, but we'll see what the explanations here are and how well it can hold up. And one of the key things we're going to see is that English social mobility is both slow but also constant all the way from 1600 till now. And the huge changes in social structures, mass education, welfare state, emancipation of women, democratization, none of them leave any trace in terms of social mobility. And it really is, shockingly unchanged. But what I'm also going to show you is it's actually true for Scandinavia as well, that their rates of social mobility correctly measured are no higher than for 18th century England. And so it's going to turn out it's not English exceptionalism. This is just a general feature of European society. But here's the good news. It turns out if we had a meritocracy, the major predictions of social outcomes would actually be genetics and chance. And so England, even before the Industrial Revolution, thus is actually functioning in the way that a meritocracy would function, in the sense that it's only people's genetic endowments and just random factors that seem to determine outcomes. And the evidence, I'm going to show you a bunch of evidence on social barriers to mobility and say that these seem to be relatively unimportant. Now, this book is based on two major sets of data. And so the first is a large genealogical database of 433,000 English people from 1600 to 2025. And here I have to have enormous gratitude to the eccentricities of the English, because most of this data was actually collected by amateur genealogists, and actually from a society called the Guild of One-Name Studies, where they commit themselves to follow all of the history of particular surnames. And so this uses people with relatively rare surnames as a way of very accurately tracing them through generations. But we test to say that, no, these look pretty average on the end. And then there's a second English group, which is a bunch of anarchist genealogists who object to the large commercial providers of genealogy and have set themselves the task of liberating genealogical records. And they have websites where they record something like 1.7 million marriages in England, all of the details of them from 1837 to 2022. And it's an open website, so we were able just to go pick up all of that information. And as I say, the number of person years involved in actually doing this is enormous. Because for some of the later years, we actually had to get something like an additional 8,000 observations ourselves. That exhausted an enormous amount of money just trying to collect those observations. So that's the data. And then from this data, we get something like 10 different social outcomes from various people at different times: literacy, occupational status, wealth at death, what your house value is for people still living, 1999, whether you were a company director, how old you were when you died. And so we have that on a whole bunch of people. It's not complete. There's a bunch of people who don't get that information. But the other interesting thing we get is because of this genealogical database, we get observed all kinds of people who are very distantly related. So we have 1.4 million pairs of fourth cousins. Now, most people don't actually even know who their second cousins are. So these are people who socially people are not going to interact with. They're all connected socially, though, in this data. They're all significantly correlated, even down to the level of fourth cousins. And that's a sign of a world of extremely slow social mobility, because a fourth cousin is effectively someone on a genealogical chain who would be 9 generations apart from you, because you're going down 2 separate chains, right, between the original common ancestor that you had. The common ancestor you had would be 150 years earlier for fourth cousins. And so, as I say, we get this nice characteristic then. We can observe all of these. And then from the anarchist genealogists, mainly collected earlier marriage records. So starting in 1837, when the new marriage register came in. But that has occupations of grooms and brides and fathers and father-in-laws. And it turns out we can infer a lot about social mobility, again, even from these marriage records. And in particular, the argument here is going to be what's driving this very slow rate of social mobility is a very high degree of assortment in marriage. And that this has these wider kind of social consequences, but it's essentially this very high degree of status assortment in marriage, and stable as well. The same degree now as in 1837, when most women did not have formal occupations or formal education. You can still observe this very high degree of assortment, and that actually is underlying very low rates of social mobility. And so the key finding is then that social status is much more persistent. The underlying intergenerational correlation of status is 0.8 as we go from one generation to the next. And as I say, that's never measured that high with raw data. And so I'm going to talk about, well, how come it can be that high? And even fourth cousins are still significantly correlated. And I think I said most of this. And the important thing is we literally have achieved nothing through the welfare state, the mass extension of education. None of that has done nothing if your objective was to increase rates of social mobility, right? We have the same society. And then this comes to this issue of genetics. And what I'm going to show you is that a relatively simple model of genetic transmission fits all of this data very well. And that doesn't prove that it's genetic transmission, but we do know that it's completely consistent with genetic transmission. The important thing is, though, that that's not genetic determinism, because even when genetic transmission dominates, there's still huge random elements in terms of determining outcomes. And one nice example of that is longevity. There's important genetic components in transmitting longevity, but it's still the case that the correlation of adult longevity between parent and child is only less than 0.1. It's something like 0.08. And if you take the average of both your parents, it's something like 0.14. And that is just telling us a very important lesson about life, that the most random feature of everyone's life is how long you're going to live. Occupation is inherited much, much more strongly. But, you know, there's lots of reasons to think that there will be genetic components in longevity, but it's also the case that there really is just this huge randomness, right? So between the genotype and then the phenotype, there are always this issue of randomness. So that's going to be the claim. And as I say, I think of this as a celebration of meritocracy, that we're not going to find systematically, and I'll show you examples, that social barriers really had that big an influence on people's lives in somewhere like England, even going back to the 18th century. And that this actually is a sign that we really had achieved a relatively open society in England. Now, what is the problem that lies behind all of this? So it turns out that when people try and measure social mobility, they typically run into a problem, which is that the measures available to social scientists on people's social status are very imperfect and very crude. So we have occupational status indices. For education, it's typically measured as how many years of education you've had. But that's a very crude measure, right, of what people's true educational attainment is. And what happens here is then that attempts to measure occupational status correlations in the United States suggest that we have a very highly mobile society all the way from the 19th century, and if anything, becoming less mobile. In contrast, when people have made attempts to correct the errors in this data, because if there's a lot of error in your outcome data, you'll tend to increase the measured rate of social mobility, right? And so the nature of these errors is always to make the world seem more mobile than it is. You can see you can get a vastly different picture of what the levels of social mobility are and also what the direction of change is. And so a problem that we run into in measuring transmission of status always is this problem of error. And it turns out if we're thinking about social transmission, there are actually three important parameters. So there's what's the parent to child correlation, which we'll call here B. What's the correlation of siblings? Again, a very good measure of the persistence of social status. How highly are siblings correlated? S. And what's the correlation between parents in terms of social status? And here's the strategy that the book uses to try and measure these. And what we can say is look at a genealogy here. We've got sibling 0 and sibling 1. They'll have a correlation S, but it'll be attenuated by measurement error theta. There'll be sibling 0 to their child. That'll have attenuated intergenerational correlation here. Sibling 1 to cousin 1, theta B. And then sibling 1 to cousin 0. Well, that'll be this correlation multiplied by this correlation, but the measurement error only ever appears once. And so it has this nice feature that it's only appearing once, even when you've got these multiple correlations. So that's going to be theta BS. And then this one, to get from here to here, we need to go here, 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 back down here. If they're all independent, it'll just be theta times B squared times S. And so we get in this genealogical data lots of these kind of sets of correlations. And here's a simple trick. Suppose we divide this correlation by this correlation. We divide theta S into this. We'll get an unbiased estimate of B, what the intergenerational correlation is. And similarly, if we take this correlation divided by this correlation, we'll get an unbiased estimate of S, what the sibling correlation is. And so in this genealogical data, by looking at the ratio of correlations between relatives, we can hope to wash out the measurement errors and get down to what the fundamental correlations are in overall occupational status or what true educational level is. And when we do this, and we can got all of these different outcomes. So start here with literacy. Here's the measured intergenerational correlation. And here's the correlation measure when you correct for these errors by taking these ratios. And you can see that this jumps from about 0.4 to about 0.8. And it's suggesting a much more immobile world. Question?
Yeah, so the attenuation error is theta, and you assume it to be similar across relationships, or you measure that to be similar?
So I'm, for the moment, assuming it to be the same across all relationships. That wouldn't necessarily hold because it will be different looking between, say, a man and a woman in terms of taking this measure. But if we average across all of those relationships, man, woman, man, man, woman, woman, then we'll get the same average attenuation error. So sometimes we can just deal with that by averaging. Sometimes it'll be a little worrying if we're looking back a generation, the measurement error can be different than if we're looking at contemporaneous people. So then we have to worry a little bit about, is that changing over time? But the basic strategy is going to be, assume we can correct most of this just by washing out the measurement errors. And as I say, we can then, so this is back in the 18th century, early 19th century. This is for people's house value between 1999 and 2025. And again, here's the measured correlation. Looking at the ratios of these correlations, you go back up to about 0.8. And so there is some noise here, but all of these measures are quite close to 0.8. And that's what I say, there really is this stable across time. So these are contemporaneous measures, 19th century measures, higher education, occupational status, so different aspects of mobility, that basically you have this very high, persistent, underlying correlation in terms of mobility. And we can check that. So my second book was about using surnames to measure social mobility. And in this data set, as I say, we have a bunch of people who have high status but relatively rare surnames. And we can just average over everyone in that surname group and actually, again, get a measure of what the rate of regression to the mean is. And this is in standard deviation units of their occupational status. And you can see that the estimated average here is about 0.82. And then again, for people's house value, in standard deviation units, they're approaching the mean in these rare but high status surname groups. And again, with a correlation of about 0.8. And so it turns out we can have confirming evidence that says there really is a lot of persistence of status in the world we live in. Now, next thing we do is, can we fit a genetic model to this data? And so it turns out that with additive genetic transmission, there's actually a relatively simple set of implied correlations between everyone on a family tree. And the crucial parameters they depend on first are just what's this measurement error? But that again only occurs once. What's H squared, which is the heritability of the trait. And that just says how reliably do we go from the genotype to the phenotype, right? If H squared is 1, then the genotype exactly predicts the phenotype. If H squared is a half, then there's a lot of gap between these two. And for different traits, there's different degrees of randomness in terms of predicting this. And then the other crucial parameter is M, where M is the genetic correlation in these relevant traits between parents. And it turns out to be just these three elements that for everyone on the family tree with this simple model of additive genetic transmission. And what we mean by additive genetic transmission is that each loci on the genome acts independently of the others in terms of determining the outcome, that there aren't interaction effects. There's experimental evidence that supports that idea, that this is the way transmission is being done. And what will happen is if we look at people in the family tree here, self, sibling, cousin, down to fourth cousin, if there's no marital correlation, the fraction of their genes that they share, by the time you get to fourth cousins, becomes essentially 0. If there's a 0.6 marital correlation, that's when you get dramatic differences between mating, which is just kind of random, and mating, which is genetically highly assortative. And so it keeps people a lot closer together as we move through the family tree. And then this is just the data. So we have data on all of these correlations for different outcomes. And then we also check, what about unrelated individuals in the data set? Are they arbitrarily showing some kind of correlation? And the answer here is no. Unrelated individuals show 0 correlation. And so these correlations that are showing up are not just some feature of the database. They're actually reflecting something about the relatedness of the individuals. And then we can draw a nice picture where here we have the correlation of the log of your house value. And here's the implied shared genotype with the best fitting relationship. And it turns out that the best fitting relationship implies a genetic correlation of 0.57. And it implies, again, an intergenerational correlation here of 0.79. And notice how well this data is fitting, right? I mean, this is the R squared is 0.986. These are, and so it's really, and it turns out this same picture fits every one of 9 outcomes we have for people with the same parameters, right? The one that it doesn't fit for is wealth. But wealth is not genetically transmitted, right? Wealth is passed on from parent to child or from cousin to cousin or something like that through in a different mechanism, right? But for traits like occupational status, literacy, and stuff like that, this data, this fits. Now, when I first, this has been a long time writing this book. Assembling this data has been a long, long task. And so I first kind of said, look, there's this interesting pattern in the data, something like 8 years ago at a conference. And there's a behavioral geneticist there who said, well, it's very interesting, but we know that people don't have a 0.6 genetic correlation in marriage. So something else is going on here. Since then, they have discovered that people actually do, for educational attainment, have that level of correlation. And so the whole genome studies, there are now papers published that say this is roughly, it's in the 0.5 to 0.6 range, is the underlying correlation in people's educational genotype. And so there is interesting that, there is kind of backing evidence behind this. And as I say, this is just showing the same picture for people born 1780 to 1859, men. And then this is the pattern of correlations, the underlying parameters, the R squared. It's an amazing kind of picture of the social world. Another feature that shows up in this data, so one answer to this is to say, this could all be cultural transmission, but just operating in a way that mimics genetic transmission, right? We could always write a model of some kind of cultural transmission that would have this characteristic. But one thing that's very interesting about this data is, for all of these outcomes, there's a very strong identity between sibling correlations and the parent-child correlation. That's predicted by genetic transmission. But cultural transmission, that is actually very unusual. And let me give you a concrete example. So both of my parents were from families of 12. They were both number 9 in those families. So I have 44 cousins. My father could have been raised by wolves, as far as I can tell. I asked my grandmother once, could she tell me anything about my father as a young boy? And her answer was no. She had no interest really in children. She was very fond of her oldest son. He was some kind of child prodigy. And I grew up with my 3 siblings in a household where we were treated exactly identically, identical specifications, right? We would think that we were going to be much more correlated than we were going to correlate with our parents, right? If you look at the different environment that we were growing up in, right? My father, at one stage, they had 3 bedrooms for 12 children and 2 adults, right? I had my own private bedroom, my sister did, my 2 brothers had to share. But, we had these and this will be typical, right? That parents moving from one generation to the next will have different social environment, whereas children growing up together will have very similar social environments. So it is astonishing that siblings actually are so poorly correlated. I would have thought that my correlation with my siblings, if social determination is the crucial thing, would be very close to 1 in terms of our outcomes. Okay? So the next question is, well, is this just something about the English? Are the English just this kind of sclerotic, rigid society where child follows parent in unending procession of misery? And so it turns out, though, we can get data from modern Denmark and Sweden, of a very similar form. And the reason I've actually now moved to Denmark was to get access to their data. It's just a data grab, okay? And so, and we can correct for measurement errors in the same way. With the Danish data, we can again look at kind of collateral various groups of relatives and make these corrections. And so, as I say, the picture that's normally presented, this is for educational years of educational attainment. The picture that's normally presented is the Scandinavian Nordic societies have these very high rates of mobility. Other societies like the United States, which are much more unequal, have much slower rates of social mobility. Okay. What we find, though, is for both Denmark and Sweden is if we calculate these three parameters using that same strategy as in England, look at marital correlation here. England in the 19th century, England now, Denmark now, Sweden now. They're very, very similar, right? This is with completely different sets of data here that you're estimating this. And you look at the sibling correlation, it's not quite as high in the Scandinavian, the Nordic countries. You look at the parent-child correlation, again, it's a little bit less. But it's very similar, right? And these patterns, as I say, are very similar. And here is a kind of supporting piece of evidence. And so there's this PISA standardized measures of educational attainment at age 15 that's conducted every 3 or 4 years. If you look at Denmark, all education is free up until about age 24. There's also living costs that are supplied by the government to, and I think that's means tested. And so you've got an educational environment with kind of incredibly open access to education. They've also very sharply compressed the distribution of earnings. And so household material living conditions are much less dispersed than they would be even in somewhere like Britain. Okay? And a result of that is kind of amusing is there's a restaurant we sometimes go to, which is quite nice, but where on the weekends, rather than have the servers actually serve wine, they just have a table with a bunch of full bottles of wine and you just go and help yourself. And as much wine as you want, it's cheaper than actually having people come and serve you the wine. Is just drink it all. And so so what we would think is that, well, one effect of this should be in Nordic societies is that those PISA scores, which are actually better measures of true educational attainment than years of education, should be compressed in these societies. And so this shows the standard deviation within the OECD economies of the PISA scores, and the red ones are the Nordic societies, and this is the other societies, and this is the average. And what you can see is that in the Nordic societies, they have not in any way compressed actual educational attainment at age 15. It is just as dispersed with all of their social interventions as it is in other societies, and that the appearance of much higher rates of educational mobility probably just owes to the fact that the measure of years of education is a less good measure in that society of what true underlying educational attainment is, because of the different ways that education is available to people. And it turns out also we can fit that same model of genetic transmission to modern data there. It doesn't fit quite as well as in England, but it's still like an R squared of 0.95 as opposed to 0.98. And so it's consistent with that data. So that brings us to the issue of genetic nurture. And so for some reason, geneticists don't want to believe in direct genetic transmission. And so what's claimed is that, look, there's two ways the parent genotype influences child social outcomes. One way is through direct transmission, where the child genotype now is determining child outcomes. But a second way is that the parent genotype also determines what kind of household the child grows up in. And so potentially you can have this indirect transmission where the way the genotype is working is it's creating the social environment for the child. And that's very important because then society can step in and provide that environment if someone's own parents are not providing it. And so genetic nurture is very important because it's talking about the possibilities that society can redo whatever the genetic lottery is actually going to throw out for people. And what are the attempted demonstrations of this? So first is you take the whole population, and then you estimate actual educational attainment using a polygenic predictor of educational attainment. So for everyone in this room, we could genotype you, and we could actually get a predictor of how many years of education you're likely to attain, okay? And then you get this correlation. It turns out these predictors are still not particularly good. And so you get this kind of connection between the polygenic predictor and then actual educational attainment. But then a second thing we can do is let's take siblings. They will have a difference in educational attainment, and they'll also have a difference in this predictor, right? Because remember, they inherit differently from the parents, and so there'll be some difference. And it turns out that the coefficient in this case is significantly lower. And that's been interpreted as saying, this is showing direct transmission, and this is showing genetic nurture as well. Because in this case, the siblings get all of the same genetic nurture. So all that's left here is what are the genetic differences between the siblings, and what effect is that having? And so this has been taken as kind of an indicator of the importance of genetic nurture, and you can see that it suggests that genetic nurture would be about half of the potential genetic effect. However, in statistical terms, this is a very noisy predictor still of people's outcomes. Whenever there's noise in a variable like this, it drives down the coefficient. In this case here, now when we've taken the difference in educational attainment between siblings and the difference in the predictor, what's actually happening is we've driven up the noise by now taking the difference between two variables, but we've driven down the signal. Because remember, with high correlation of the parents genetically, the siblings are going to be highly correlated. And so the amount of difference in EA4 is going to be much smaller, and the amount of difference in educational attainment will be much smaller. And so another interpretation of this is just you increase noise, you reduce signal, you get a less good predictor in that case. It tells us nothing about genetic nurture. And then I'm going to skip, there's another demonstration of this, but it would take too long to explain. And this one actually, what it does is the children only inherit half of the parents' DNA. So it predicts child outcomes using their own DNA and the half of the DNA they didn't inherit. And it finds that that DNA they did not inherit is also predictive of their outcomes. And the idea is, well, that must be, there's some causal connection. It must be through social outcomes. However, if there's strong genetic assortment of parents and still an imperfect genetic predictor, the parent DNA they didn't inherit will also be a predictor of the underlying genetic value of their DNA, right, in terms of educational outcomes. And the parent DNA they didn't inherit will just be a signal of what we don't observe currently in terms of their own genome. And so it turns out that that it's still wildly kind of controversial actually whether genetic nurture exists or not, right? And as I say, I don't think there are any convincing demonstrations of this. And so what I want to then say a little bit about is, well, can we test whether genetic transmission really looks plausible? And it turns out that the great thing about genetic transmission, unlike cultural transmission, is it has very clear and explicit empirical predictions. One of them is there should be almost complete gender symmetry. Your mother and your father should be equally important in your life outcomes. And that's interesting because mothers still spend much more time with children than fathers do. And so on cultural transmission theories, it really should be the mothers that significantly matter, and also the matriline should be more important in terms of determining outcomes. A second thing is family size on these genetic, if there's mainly just direct genetic transmission, family size shouldn't matter. Birth order, again, should not matter, right? You've got the same genetic lottery as you move down the birth order. Your place of birth should not matter. So the north of England does much less well than the south of England now in terms of almost all social outcomes. If it's the case that just being born in the north predicts that you'll have a lower outcome than just being born in the south, that would be a sign of important social transmission. And so the place of birth should actually not matter if this is going to be correct. Adult longevity, again, the question is, there's a strong claim for social causation of longevity because high status people always live significantly longer than lower status people. And this has been argued to be the stresses associated with lower status work, the living conditions associated with lower status work. But if we found a way of kind of modifying social conditions, but didn't change people's status, would we actually observe a change in longevity? I don't think I'll have time to go through that one, but another one we will have time is, what about if your parents die soon after you're born? Does that significantly affect your life outcomes? And again, there's been a lot of play in anthropology and the idea of grandparents as important elements in the economy and social life of families. And again, we could say, well, what if your grandparents were dead when you were born? Does that change your social outcomes? And then another thing is the linearity of effects. If it's transmission through additive genetic effects, you should observe just a very linear relationship between parent outcome and child outcome. And there are certain patterns that you could observe that would say, no, that's got to be social transmission. And so if there's a poverty trap or a wealth trap, that would be a sign that social elements and transmission really matter, because if it's through genetic transmission, there should be no poverty trap. People at the bottom are the ones who move up most towards the mean. And you don't get people trapped in these kind of lower status situations. And so to test whether mothers matter as much as fathers, we get two tests. One is we do observe mother and father literacy in the 18th and 19th century. But in other cases, we can use father and brothers as just proxies for the mothers, because the mothers don't have explicit educational or occupational status. And for literacy, this is estimating what's the effect of mothers versus relative to fathers, where one is the effect of fathers on child outcomes for occupation, literacy of you and your spouse, whether you're at work or at school at various ages, and higher education. And you could see that in most of those cases, it predicts equally, mother and father, right? And there really is a symmetry here, except for this one case of higher education, where we do get some deviation in favor of mothers. And then, as I say, the other thing is to proxy for father and mother using grandparents or using brothers, right? To proxy for their status, and then say which predicts better what the child's status will be, the matriline or the patriline, okay? And when we do that, what you see, this is the paternal predictive effect, and this is the maternal effect, and this is for literacy, this is for wealth. There again, you see the patriline matters. For wealth, the matriline much less. This is for occupational status, that if statistically the same. This is for higher education, statistically it's the same. You inherit as much from one side as from the other, despite the appalling negligence of most fathers. And then this is using uncles. And you can see again that there's just no difference in terms of the predictive power of the matriline or the patriline. And the important thing here is you should be saying to yourself, that's unexpected. That's not really my kind of picture of the world, right? Because it isn't, I think, for most people, their picture of how the social world operates. And then when we look across all the different ways in which this is where the patriline is more important, and this is where the matriline is more important, you can see it's just a random collection centered around zero here. And the kind of convincing evidence is it's symmetrical, right? Family size and child outcomes. Now, this is a speech to economists here, which is economics has this doctrine of human capital at its center. There is almost no evidence that things like family size actually make a difference to child outcomes, even though this is a central doctrine. And the way that people have tried to study this is by using cases where people have twins, you get an unexpected increase in family size, or where, because the first two children have the same gender, it increases the probability of a third birth. But the problems they have with these measures are that twinning only occurs traditionally in about 1% of all births. And so you end up with very small sample sizes, and you're looking at modest changes, right? And again, the effect of same gender, on increasing family size is very modest. There's only some families that respond to that. And so you get very modest effects. And so Damien Clark in 2018, no relation, looks at 10 estimates of the effect of an additional child. The average estimate was minus 0.1 years of having an additional child, but it was statistically insignificantly different from zero. And so the prevailing economic evidence does not show any evidence that family size actually makes a difference to people's outcomes. For marriages in England from 1780 to 1879, we know there's no attempt to control fertility. And the way we observe that is what happens if you have a twin, say at birth 8? What happens is you have one additional child. People don't respond in any way by reducing the number of births to having an additional birth through a twin. And they behave as though there's just no behavioral response. And the only systematic determinant of family size is the wife's age at marriage. And it's also the case in this period that if we look at, say, number of children who reach age 14 or 21, it's largely independent of father occupational status. And so there really isn't a strong occupational gradient in this period. And so families, the thing that matters is for all marriages, here's the distribution of numbers of children. And so you get this huge variation in numbers of children. And even if we look at marriages where the bride was aged 21 to 25, and these are all marriages where people lived to at least age 50, and there was a single marriage, right? So we're just focusing on these cases. You can see that there's still a bunch of marriages that produce one child and a bunch that produce 9. Completely unpredictable from the observed features of these families. And so you get these enormous shocks in terms of family size. And it's also the case that in this period, this is average families, how many are still in training or education at each age, and this is elite families, how many are in training or education. So human capital investment is very important. Wealth is strongly affected again by family size. So this is your wealth relative to your father. The bigger the family, this is for families where wealth is being inherited. It has this initial effect, right? So you can see that, as I say, wealth systematically behaves differently. But if we take here occupational status as a function of family size, it has 0 effect. If we take whether you're at school or not at age 14, using ages 5 to 6 as a reference, again, there's no sign of any effect. Okay? And so, as I say, family size doesn't seem to matter, right? So my parents and their family size of 12, no problem. It doesn't seem to make any difference. Now, what about birth order? And so this is where we use a lot of regression techniques, estimation techniques. There are lots of bizarre things that occur when you use such techniques. And it turns out with birth order, these actually appear. And so there's a very famous study by Black et al. In Norway at birth order effects, where this is the estimated effects of birth order in a number of years of education. And you can see it's quite significant and negative. However, you also have to control looking at birth order effects for parent age. And the interesting thing is you can't be number 3 on the birth order compared to number 2 without having older parents. And in some sense, though, then those effects are actually completely intertwined, right? Now, you should be able to estimate them because the parent gap in terms of years is different across different families. And so the regression analysis should be able, with enough data, to sort out the pure birth order effects from the parent age effect. But look what happens here once you add parent-mother age effects in Norway, and then you take what's the average effect of these two, it disappears, the birth order effect. And it turns out this happens systematically in these estimates, that birth order effects can appear, but typically there's a counterbalancing effect that older parents are better, and the two effects roughly cancel each other out. And so I think this is largely just a kind of pathology of regression estimates, that somehow it's fitting the data, but it's not revealing the underlying causal structure. And you always have to be very cautious. But it turns out when we estimate for the English data, birth order effect, so this is the estimated pure birth order effect, and then this is parent age adjusted. You can see that in almost all of the modern data, there is no significant birth order effects. And the axis here is in standard deviation units. So we're talking about less than 0.01 of a standard deviation unit of becoming one further down in the birth order. So the quantitative magnitude is trivial. And then here's birth order and occupational status for different groups of families in the 19th century. It doesn't matter, right? And so if you've been thinking, if only I'd been a first child, forget it, right? It really doesn't seem to matter. One of the things is there is a subtlety, which is for rich families, the oldest child did have some birth order gain. And you can actually observe that in the data, right? They're much more likely to go to Oxford or Cambridge, and they're going to have higher wealth than their siblings, and they're more likely to get education in general. But it turns out they're a very small part of the data. So once you have all of the data here, it's actually very hard even to observe that effect in rich families. And so we've said something about regions. So these are the regions of England and Wales, and I've divided up the country and taken East London, Southeast, and Southwest as the South, and then here you are, the North. Okay. And then for all kinds of things, what's the employment rate aged 16 to 64? You'll see the South does better, the North does less well. And so there's this systematic difference now between North and South of England. And it turns out there have been a lot of migration flows, both from North to South and South to North, that we can observe in the data. So we can observe where people are born and where they die. And this is the percentage of each generation that flowed from North to South. And so the predominant flow now is North-South. And then this is the flow from South to North. And in the Industrial Revolution period, those flows actually were equalized. And what we also observe in the marriage database is that over time, the North and the South have diverged in average occupational status. And the South now is significantly higher than the North, okay? And the question that comes up is there just a disadvantage from being born in the North that's causing this divergence? Or is all of this divergence being caused by selective migration of people of higher social status out of the North? And so we can measure migration. We can look at people going from North to South all the way back to the births in the 18th century. And what you actually observe is these top group here are people, men moving from North to South. They systematically have much higher status than the other groups in this data. And if you observe those going from South to North, you can see that there's a big difference in status. And so there's been, all the way back even to the 18th century, a persistent movement of status, higher status people from the North to the South of England. And it's a little mysterious to me, why is everyone heading south? Except I grew up in Glasgow. The weather is something that's a little difficult to get used to in the North, right? And what we can actually do then is we can look at the average status gap between South and North. And so you'll see that there's a gap in occupational status. This is the actual North-South gap, and that has actually increased significantly over time. So in the early 19th century, that gap did not exist, but now it's there. But then we can take into account people who migrated. And if we assume that people's status is generated by their genetics, any migrant, it permanently affects the genetic stock of North and South, and will have a permanent effect on the outcomes in the South compared to the North. And we can then predict, well, what should have happened with the character of migration that we observed in this North-South gap. And it turns out it predicts fairly well. And what it's saying is there isn't an economic problem of the north of England. The world is as good as it could be. It's just a sorting that's occurred between people of higher potential economic status in the south and those in the north, right? And there's no kind of structural problem that people need to deal with. And then another way of seeing this is this shows the groom status relative to their father status throughout this period. And what you actually see is, on average, grooms relative to the fathers, you can see a period of status growth by grooms in more recent years. But what you can see is that that's actually as strong or stronger in the north as it is in the south. So once we control for your father's status, people in the north are acquiring occupational statuses that are actually as good or better than people in the south. Here, it's a little bit reversed, but if we take the whole period here, on average, it's exactly the same. And so what we don't observe is that somehow, relative to their fathers, people in the north are slipping behind in terms of occupational status. We observe that they're doing just as well. But we do observe this transition going on from north to south. And as I say, again, this is why I think there's good news in this paper, because it's things that people thought were a social problem turn out to say, no, it's just people sorted, right? And people always sort within societies. What about dead parents and dead grandparents? This looks at the son occupational status for two living parents by the time you reach age 14, a mother who's dead, a father who's dead by 14, and then both parents are dead. And this is the confidence interval, 95% confidence interval. And you can see that, amazingly, it doesn't make any difference to people's outcome whether they lost a parent. Even losing two parents, right? You don't see any effect. Now, you might think, well, what I think this says is social institutions actually were reasonably good. So I can see in the data what happens to these families when they lose parents. And what is actually happening is grandparents take in children, aunts and uncles take in children. At the worst, you go to the workhouse, but the workhouse supplies nutrition and schooling to children. And again, siblings, right? With large families, children tend to die at the younger end of the family. Often there's a sibling who will then take care of these children. And so it actually says that the social mechanisms are good enough that you really don't see any kind of dramatic effect. And then this is the fraction who are at school age 14. That actually declines slightly in the case where the mother dies. But it's really small decline. And the important thing is the occupation data is saying that you catch up later. It turns out this is a general result that's been found in Sweden, I think in the Netherlands as well, that even in the 19th century, death of a parent did not actually have much effect on people's social outcomes. The other thing is, when a father dies, often that father is replaced by a stepfather. And so what you would expect is that those two fathers will not be perfectly correlated, and that consequently the correlation in outcomes between the son and the father when the father has died will actually decline. And this shows father age of death from 0 to 13, 14 to 20, or 21 plus. And there's a very slight evidence here that maybe there's a little bit of effect, right? But it's actually not statistically significant, right? And again, this is for education, this is for occupation. It just doesn't seem to matter. So whether you ever met your father or not, it's not going to change your life. Okay. And then what about grandparents? So here we can look at when you were born, were your grandparents still alive? What happens to your average level of outcome? If anything here, if your grandfather was dead, you're better off, right, in this data, but it's very minor. It just doesn't matter again, the grandparents. What's the predictive power of the grandfather? So we include, okay, wrap it up, yeah. If we include the grandfather and the father in a regression, how well does the grandfather predict? If you actually met him or didn't meet him, it makes no difference, right? And so the grand conclusion here, we have to stop, is that amazingly, there's very powerful evidence that direct genetic transmission is the main determinant of people's life in a society like England or in Nordic countries, and that actually also is a sign that we have actually achieved a relatively high degree of meritocracy in societies like England or the Netherlands, where people's accidents of birth are not that important in terms of the final outcomes of people, and that social mechanisms exist that actually allow for people's outcomes to be determined by their, mainly, as I say, their genetic potential. Thank you.